Not long time ago I read an article on how to 3D print attenuators, and there I found a suggestion that for 4x attenuation I need to put 1 mega ohm resistor in series and then 500 kilo ohm to ground, and that's it. This is what supposedly makes a 4x attenuator. But how does that work in practice? Let's find out. So what I did, I built such a device and put it under test with a oscilloscope 2204A. So I have a signal generator going to the input of the attenuator, then 1 mega ohm in series, and then I have two 1 mega ohm resistors in parallel. That makes it 500 kilo ohm going to ground. Okay, we are ready to do the test. So let's open a fresh copy of oscilloscope and start the capture. But first we need to set up the signal generator. So let me choose the sine wave, 1 kilohertz, 1 volt amplitude, and we have a nice sine wave. Let me put it to plus minus 2 volts and set up the trigger. And here we go. We have a nice sine wave. What do we have on channel B? So let's enable channel B, and we have something that is pretty much 4x attenuated trace of the original signal. Let's change the voltage to 500 millivolts, and if it's indeed 4x attenuation, then the traces should overlay on each other, and they do. So nice. We do have 4x attenuation when we feed the device with a 1 kilohertz sine wave. However, if I increase the frequency to 31 kilohertz and of course adjust the time base, we will notice that it is not the case anymore. The red trace is significantly different from the blue one. Let's fire up the cursors and see what's going on. So we have 950 millivolts on the blue trace and only 169 millivolts on the red trace, even though we should have around 952 divided by 4, 238 millivolts. Instead we have 169, which is 71% of what we need. Also, notice that the phase is different. So the difference between peaks for the red and blue trace is around 4 microseconds. Things get even more interesting if we try to use the square waves. Even at 10 kilohertz square wave, we are going to see significant distortion of the signal. So the blue trace is our original square wave, and it's not perfect because the signal generator in oscilloscope 2204A is not that great. So the rise for the signal takes around 4 microseconds. However, for the red trace to get to the to settle, it takes about 22 microseconds, or maybe even a little bit more. And the same thing happens with the falling signal. So let me change the trigger to the falling, and we again see that it takes about 24 microseconds for the signal to go down. So the question is, what's happening? Obviously the device that we made is not achieving 4x attenuation for let's say 10 kilohertz square wave or 31 kilohertz sine waves, so it's not working as advertised. So the question here is what's going on, how to fix it, is the circuit missing any vital components, and also I have the waveforms here for you, for the sine wave and for the square wave. From them, can you figure out the values of the components that we need to put into the circuit to fix this problem? Alright, this is it for today. I have a great question for you here, and please write me in the comments what you think, and later I will do the follow-up video where we can discuss the fix and the reasons for such behavior that we just observed on the oscilloscope.